These lessons we discussed how to cost the operation of an equipment. With that, we have two learning objectives. We calculate the hourly owning costs of construction equipment, and we calculate the hourly operating costs of construction equipment. So there are two type of costs that we consider: ownership cost, how much we can own, and then the hourly operating costs, so that we can be able to determine the costs that we can operate and maintain and own an equipment. So let's break down the equipment costs. As you the objective imply, we have ownership costs or owning costs and operating costs of an equipment. In terms of the owning costs, what is included? First, the depreciation that you learn in project planning. You buy properties, or you buy an equipment or a machine, then you can be able to depreciate over time the life of the project, and that depreciation consider a deduction in the tax for the tax purposes, as we already learned. So that we spend the money to buy the equipment, and that become a depreciation that we can charge into the costs for the ownership when we use that to do the construction work. And that is one item of the ownership cost, which is depreciation. Investment cost. No one have money to buy every equipment. We need to get money from the bank, borrow money, etc. Money is not free. We have to pay the interest, and that called investment costs. Just like we buy a car, we take a car loan, then we have to pay the interest. That is the investment costs in these scenarios. Insurance costs, that the name implies, is straightforward for you. Just like buy a car, you have insurance. Similarly, for the equipment, we have insurance, and it not only for the equipment itself, the safety involved, potential accident, etc. Taxes and storage costs. If the project we don't have work for the equipment, for the machine, where we are storage, everything associated with the cost, and that is the components for the owning costs of an equipment. Now, in terms of operating cost, which is we have to spend for any hour that we operate the equipment, that including, of course, fuel, and then service associated with that. At some point, we have repair, tire we have to replace, any special item that we need to have, and then the operator wages. That's something we touched on in the previous lesson of this class. That also include in operating costs. So for today's lesson, we apply this concept to determine the owning cost in terms of the depreciation and investment, and then insurance, taxes, and storage costs. And we also determine the operating cost for the fuel, for the service, for the repair costs for the equipment. And we use different tables, but before, I just want to capture some depreciation costs involved in here. For depreciation portion of the ownership cost, which is the first item here, how can we determine? There are two methods that we can do. The first method is the most accurate, and you learn that in project planning concept, that is the time value of money, and that is the most accurate because they consider the cost of investment, interest, etc. And then the second method is quicker. We don't need to have a knowledge of unvalue, time value of money. That we call average investment method, AI method. And it's in that method, for the depreciation portion, we have the cost of money portion and depreciation portion. And this is approximate, it's not accurate. And for the average investment, it can be determined by the average between the initial cost that we spend to buy the equipment and the service values that we resell the equipment after the useful life. So the average, so it divide by 2, that sum divide by 2, that we have average investment. And in the problem 1, we'll be able to use both method, and you see the difference for determining the depreciation portion of the ownership costs for an equipment. And then we go to the operating cost. We use multiple table, and it's available on the final exam reference. I just go over a bit in here. The first is the operation cost, include the fuel consumptions, and it depends on the type of equipment, just like different car you use, pickup truck or sedan, or even Tesla. Then the fuel consumption are not the same, so that is type of equipment. The loading conditions also a factor in terms of when we talk about the fuel consumption. If we go in the road with the level smooth, then the fuel consumption is less compared to you go to the hill, etc. The same apply for construction equipment. The load condition is low, average, or severe. Sometimes we need to make assumption based on the actual condition. And in this case, each number here is measured by the gallon per hours per horsepower of the equipment, because each equipment may have different horsepower. More horsepower, more fuel consumption. So again, the unit of this table 17.1 is gallon per hour per horsepower. And then the service cost, that is the service. It also depends on the operating condition. If it's severe condition on the mountains, etc., or near the ocean, then it more erosion, things like that. Then the operating condition will detect the service cost factor, and that factor in terms of percent here is measured by the percent of hourly fuel cost. So if we already determine the fuel costs with the table in the previous slide, then we can be able to determine this hourly service cost for that equipment based on the percentage of the hourly fuel cost. And we have another table to determine the typical lifetime repair costs, and that have for different equipment and operation condition as well, and it percent of the initial costs less tires, and that is typical lifetime repair cost. And then that is lifetime, the equipment can last for 5 years or 10 years. How can we determine the repair costs for year 1, year 2, year 3, etc.? In the final exam reference, you have that equation, and then you can imagine, just like when you drive the car, if you have a new car, the first year maintenance cost is very low compared to later years, so that important to consider as well. And then the last table that I want to show, that is the typical tire life in terms of hours. So depends on the equipment, depends on condition, we can be able to find out what is the tire life in terms of hours of operation for each equipment in here. So if the problem don't give you the life of a tire in terms of the hours of operation, you can be able to use this table to determine that.